Dude, Adam really likes his son, and they don't do that one. So he's proud of you. He's like, everything starts being like, you're so in school, you're a bum. No future. Make you spend more money in school and flaunt the like. Oh, it's too good. I'm glad Denise called him and shit. It's actually got no, like, dude, actually, he's literally abominating.
It works this entire time that you've been on the show. Worked with him and on this and so
No, they're going to be scared, dude. I didn't really like that.
they just had to have a reason to keep her on the show. Which she's sit there without being with him.
Okay, I will say Redbird killed me. Redbird? His crush. Like,
Oh, no. Say what?
I'm so shocked that
They really an ad for Hartford medication that he was like holding up some medication that was like signaling an ad or something. It's like I guess that was for nothing.
I'm gonna just miss Jeremiah.
Yeah. No, she's not on.
She's coming. She's like,
Okay. It's not a different one. I want to finish the last questions. That we didn't get through. There's like 10 left. Honestly, I should make you do it again because it was rough for a lot of you.
it's gonna be.
It was rough for almost all of you except his, bro.
Not even.
Were you taking it? I was enjoying it. Yeah. You were still on top by the end of it. I was like, she's still answering. She's still number one.
I was like, thank God the Pearl High got around it.
69% on check.
Oh,
I'm changing it up today. It's feeling funny. How do we feel about the questions yesterday? And she was still beating off you.
she was reading. I was like, wouldn't it be so fun? I still like
And still, by the time I ended it, no one's got. And you're the only one that can tell is the other two. I can't tell who they are, so I don't know who's number 2 and number 3 yesterday. If you wanna.
It was me and Ben.
Oh, okay. Okay. Anybody else? I'm gonna end this 21. We had 22 yesterday. I'm gonna start it. Okay. I'm gonna skip to the end unless we want to go over the questions again. I mean, the people that got them right, no, but okay.
So.
I scroll this up. Yeah, done. Is this the last one we talked about taxing with a left quartering tailwind? Yeah, answer this one again, because we were rushed at the end.
Sit right then.
We're finishing the questions we didn't get to yesterday, not the whole thing again.
That was actually really fun on Zoom.
It was.
Yeah, yeah, it was really fun.
I was good.
Name's killing it.
Mhm.
Absolutely. That's not good for us. Here too. Alright, can you hold that?
Oh, yeah.
Put up.
Me.
Thanks. Thank you.
Alright, we ended, I think, on this one yesterday, but we'll just redo this because we were going very fast at the end. Other than Abby, there's still one more person. I have 2 minutes. Am is still answering. And would you like to answer?
Twice.
Oh. Alright, we'll end the timer then. Okay. 77. Not bad. Okay, taxing with a left quartering tailwind. That means the wind's coming from behind us, right? So the way that we correct for a tailwind and a headwind is different when we're taxing. So if the wind is behind us, we do something called diving away from the wind. So that means we go in the opposite direction, aileron, and fully forward on the stick. Diving away, diving forward away from the wind. If the wind's in front of us in a headwind, we're going into the wind and neutralize. You do a little, not really back pressure, but more neutral on the ailerons, but you're going into the wind if it's in front of you. And then if the wind's behind you, you're diving away from the wind. Okay? So that's going to be fully right for a left quartering tailwind and control wheel forward. Okay. We went over this yesterday, but it was fast. So, and you should be doing this correction while you're taxiing with your instructor. So if they haven't gone over taxiing, how to do wind correction while you're taxiing, practice that with them next time. Okay. Detonation occurs when More people attend, like. Molly, does it keep doing a weird thing with yours?
Yeah, I had join choices when I did the first time, just when it.
Oh, okay, so this one isn't even active,
Yeah,
so I can remove it?
yeah.
Okay. Sweet. Okay. Not the best. 66. Detonation is the explosive ignition of the fuel and air mixture within the cylinder's combustion chamber. What is this one that other people answered? Ignites prior to the engine's normal ignition point. That's pre-ignition. Detonation, explosive ignition within the combustion chamber. Pre-ignition, there's that prior to the normal ignition point, pre-ignition, okay? How does frost affect the lifting surfaces of an airplane on takeoff? We talked about frost yesterday for the first time. Maybe you've done some at-home study. Or you could just, using your weather knowledge, take an educated guess. Okay. How does frost affect the lifting surfaces on airplane on takeoff? Oh, the timer ended and none of you, not all of you answered. Okay, it already shows the answer, so I won't go back, but frost may prevent the airplane from becoming airborne at a normal takeoff speed because the frost is changing the camber of the wing, it's changing the surface of the wing and the airflow over the top of it, but that does not increase lift during takeoff. Okay, so that's where this one's wrong. It's not increasing lift during takeoff, it's hindering the amount of lift that can be produced on takeoff. So it may prevent the plane from becoming airborne at your normal rotation speed. It will probably take more airspeed to be able to produce the same amount of lift with frost on the wings, okay? So that's probably one of just reading the whole answer instead of the first part of the answer, but it's not going to increase lift. It's going to do the opposite. Okay, next, I'll add on the timer. Which incident requires an immediate notification to be made to the nearest NTSB field office? Immediate notification. Morning. Okay. Oh, jeez. Okay. Okay. An in-flight generator or alternator failure is the correct answer. This is a major component of the aircraft. It's a major failure in the aircraft. Your generator or your alternator, especially in our plane, is the source of our power for our engine. So if we have a generator failure, we've lost our engine. That's specific to Sling, but also in other planes that use a generator or an alternator or their electric power, a failure of that component is a major failure. So that's something that would require immediate notification. An overdue aircraft is not an immediate notification. That is believed to be involved in the accident, but you don't have any of the information. It's the overdue aircraft that is believed is not an immediate notification. You would notify them if you believed an aircraft was in an accident, but that's not an immediate notification, because all you know is that it's overdue. Just because you believe it to be involved in an accident doesn't mean it's immediate. An immediate is a major failure of flight components or the engine for the airplane, okay? Okay, center of gravity can be found by what? Weight times arm, multiplying weight times arm, dividing total weight by total moment, or dividing total moment by total weight. I'm gonna add. Okay, get your answers in. Don't be looking it up and then putting the answer in.
Right.
It should be, you should be able to answer this pretty fast. CG, what do we do at the end of our weight imbalance? How do we find CG? 10 seconds. Okay, not great. I was expecting this. Okay. I'm going to teach you something that Jimbo taught my private class. Think for CG is your mom's overweight. Jimbo taught me this. Your mom's overweight, mom is moment, M-O-M. Mom's overweight. Moment divided by weight. Okay? Dividing total moment by total weight. Okay, it works. I can't fault him for it. I don't know if he actually came up with that or he just taught us that, but that comes from Jimbo if you're offended by that. But okay. Mom's overweight is how you remember. Moment divided by weight. Because that moment is a huge number, right? That moment is a gigantic number that you get at the back of your weight imbalance, the last column. So you divide that gigantic number by your total weight. It should be under your max gross weight, 1320, okay? And that's how you get like 6'8", 6'9" to 7'1". Don't sorry. We're not 12 years old. Don't start that. Next, when may an emergency locator transmitter be tested? We haven't gone over this. This is a written question. We talked about the ELT. We know when it needs to be inspected. But when can you test that the ELT signal is working? There's a specific time or any time. Like, excuse me.
Oh.
Or any time. But when can you test? Okay. At least no one answered any time. Okay. Yeah, I didn't add the time on that, so if you didn't get it, you just didn't know it yet. But it's during the first 5 minutes after the hour is when you can turn on the switch, test that the signal is working without contacting emergency services. If you're testing, if the signal turns on during the first 5 minutes after the hour, they assume that's testing the signal. Now, if it stays on after 5 minutes, then you're signaling a real emergency. But if you want to test the ELT signal, it has to be during the first 5 minutes after the hour. Okay? It's a written question. The last one. Which type of weather briefing should a pilot request when departing within the hour if no preliminary weather information has been received? Ooh. Okay. Standard briefing, right? Can I see who's the one person who said a briefing? I probably can at the end. It's not like I can tell your username and unless someone's your real names. Why is it not abbreviated briefing?
Yes.
Yeah, no preliminary weather information has been received, so you always start with the standard. Most people got that, but maybe you just pressed the wrong button.
Dude. What?
Okay. We're gonna assume the same standing from the last quiz. Tiff still dominated on that.
Got it.
Yeah.
Because it's like, it's not eight. It doesn't, yeah, it's just, oh, it's in here.
Oh, yeah.
Yeah.
President.
Oh, wait.
Who's present?
It's like.
Oh, you came in? I saw you on Zoom.
So high.
You all love doing that. You're doing a lot.
No, yes, it doesn't mean it's Ohio people, bro. Oh.
Not my expertise. You know we're on the same time. Don't ask me that. Who's in their teens in here? They can answer that question. It would not be me.
Yeah.
You cannot be the only one. Who else is under 20 in here? Molly, you're under 20? Jake's under 20? Okay. Yikes.
Except that they're both white. Even one on board. No, I didn't hear. I didn't know. Wait, no. Oh.
Right there.
Ask me what you want to ask me.
Dude.
Okay, let's review.
No, it's not what I said. It's not. I don't know. I don't know.
Ask your fellow.
It doesn't, they don't know. Doesn't need to be here. It doesn't have to be. They're making things up there.
It's hard to tell now. Now everything means people start with one meaning and then you end up with something completely different. It's like fringy. Once it becomes fringy, then it means like the opposite of what it originally means.
Or just people stop using it.
Yeah.
I consider.
Yeah, I feel like Ohio was like it's not way long ago.
Like 20. You go get your nails done.
No, these are press on.
Really?
Mhm.
Has the other ones been tested?
Yeah.
too?
I don't have the money for I don't have the money for nails. These are the glue is really good. These are called lamnetic. I love them. They're like really sturdy material. And the glue I usually get like 2 weeks out of these. I get them at Ulta or Amazon. Mhm. I usually get like 2 full weeks. The third week's like some of them are popping off. Not great glue on whatever, but I'm a press on nail girl. I can't pay for the gel or
I know very question. Should I just see your minutes?
Okay, who has weather questions? Do we know everything about weather we need to know? Okay, go ahead.
Talk about. Yeah,
Sure.
like the states.
Yeah.
Whoa, don't laugh, that's fine, don't laugh, don't laugh.
Why are we laughing?
I got
This whole week is review. We have to review
Preparation.
everything. You wanna go over the troposphere? Are we just saying words now?
We're right there.
Let's go over the layers first. We'll get down. I'll have to technically have to get through all the slides to make sure we did the review. So we'll run through these, hit everything really fast. Stop me if there's something you want clarification on. Please don't be shy. Just ask me to go over it again or clarify something. Okay, biggest layers of the atmosphere that we need to know are the troposphere and the stratosphere, and what's between the troposphere and the stratosphere? Tropopause. It's not on here, but what is the tropopause?
It's a layer that all the weather.
Exactly. It's like a lid on the troposphere that keeps most of the weather in the troposphere, and a little bit gets to the stratosphere, but not much. Most weather we are seeing is going to be in the troposphere, and we have a tropopause that kind of acts like a lid, keeping all that weather in the troposphere, and then the stratosphere above that. Do we need to know the, yeah, question? Please go ahead. We don't, I've never been asked the feet over the equator region, so you don't have to memorize any of this. If anything, you can look it up. If you have to, they ask me this, but what is the biggest part? If we're talking about the vast majority of weather, clouds, storms occurs, temperature variances occur in the troposphere, then we are talking about the temperature decrease at a rate of 2 degrees Celsius every 1,000 feet of altitude. What is this called? This is our standard lapse rate. Okay, minus 2 degrees Celsius every 1,000 feet of altitude. That's what we're taking from the troposphere slide. So the pause, like I said, it's like a boundary layer. It traps the moisture, therefore the associated weather in the troposphere. The rest of it is fun to know if you want to know it, but it's not important to what we're talking about. You can also think of it as it's commonly associated with the location of the jet stream. If you remember us talking about the jet stream. All right, mesosphere. It has the highest clouds in the Earth's atmosphere. We're not asked about the mesosphere very often, but there's a very scarce amount of water vapor up there, so they form something called, however you pronounce that, clouds. Never been asked about those before either, but very scarce water vapor means clouds are not very present in this layer of the atmosphere, right? And it's getting colder with altitude, just as the other layers of the atmosphere. Then we get above that to the thermosphere. Now we're increasing, it doesn't have it on here again. Maybe I just type it. No, won't let me edit it. Okay, it's increasing temperature with altitude due to the very low density of molecules that are up there. It's cloud and water vapor free. So the mesosphere has a little bit of water vapor that creates these type of clouds. They're considered the highest clouds in the Earth's atmosphere. Thermosphere, we have no water vapor, therefore we have no clouds. Okay. This is fun fact. You can see the aurora borealis and the aurora australis, and this is where the space station orbits, in the thermosphere. So we're not flying rockets into space or going to the International Space Station, so not really concerned. Okay, how does air circulate in the atmosphere? We're talking about warm air rising. Because of that heat, the molecules, when they're heated, start to bounce around, spread apart from each other, creating less dense air. That less dense air is rising. As it rises, it expands, becomes less dense and lighter. That's why it rises. Then cool, heavy air, as it gets colder, it gets more dense, those molecules pack back together, and denser, heavier air sinks. So now you have a circulation pattern of air, warm air rising, cold air sinking, back into heated up again and it's rising. Now it's falling and it's getting colder and it's sinking, and again and again and again. Okay? Do we understand the basics of why warm air rises and cold air sinks when we're talking about molecules in the air? Yeah. Some of us are looking around, maybe not. Okay. Speak now, please, if you don't understand. Yeah, this is why in the equator, solar heating is, we have the most solar heating around the equator. So we have a lot of rising, less dense air at the equator, that as it rises in the air, it moves towards the North Pole. It gets colder. As it gets colder, those molecules pack back together. They get dense. They fall back, they sink back down. Okay? Atmospheric stability, biggest point. Atmospheric stability depends on its ability to resist vertical motion. Any type of vertical motion means you are having unstable air. Okay? That's why we're talking about low pressure systems, rising air, unstable air. Talking about thunderstorms, unstable air, that's that rising air. Cold fronts are pushing warm fronts up. That's that rising air again. Vertical motion, rising air is unstable. So a stability of the atmosphere depends on its ability to resist vertical motion. You will be asked this. Yeah, stable atmosphere means vertical movement is difficult. I said that. Yeah, if it's unstable, small vertical air movements tend to become larger and larger, resulting in turbulent airflow and ultimately convective activity. We're talking about convective activity. What are we talking about? Thunderstorms. This is back to convective segments. Remember tornadoes, squall line, embedded thunderstorms, etc., etc. We'll probably get back to that at the end of this slide, so we'll come back to segments. But yeah, extensive vertical clouds also created by instability, leading to turbulence. Those big, tall, fluffy white clouds, that's indicating vertical movement, means unstable. Okay, I think I already went over all that. Then atmospheric stability, we're talking about unstable versus stable air. You have indicators of unstable and stable air, right? So unstable air has those big, fluffy, tall clouds, cumuliform types of clouds. Cumulus clouds are under the umbrella of cumuliform clouds, right? So cumuliform clouds, cumulus clouds, same thing. Showery precipitation, rough air turbulence. We already talked about how turbulence is created by unstable air. And then good visibility, because that moving air is moving out the clouds and the fog that could be obstructing your visibility, right? That there's movement in the air that's moving that out of the way, compared to stable air, smooth air, continuous precipitation, stratiform, those flatter, heavier clouds and fog are staying stationary because there's no movement in the air, no vertical movement to move them out of the way. So you get fair to poor visibility because that fog and clouds are staying in the area. They're not moving. So you have poor visibility. Yeah.
For unstable air, for the good visibility, is that because the clouds continue to be up?
Yeah.
Out of your way, not outward, right?
Not outward. It's
Towards
moving them
up.
up for visibility. Yeah, out of your way. So you have better visibility.
So basically, it's not resisting,
Exactly.
right?
Yeah, because it's not able to resist vertical movement. It's moving all of those clouds. As there's fog, it's moving fog up out of your line of sight, out of your, now you have better visibility because it keeps moving that air upwards. Okay, the adiabatic process, back to the standard lapse rate. There's a lot of words again. La 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 la. Okay, This adiabatic process is talking about the standard lapse rate, average rate of temperature change is -2 degrees Celsius per 1,000 feet. Then we talk about how water vapor, moist air, now we have specifically a moist adiabatic lapse rate and a dry adiabatic lapse rate. So water vapor is lighter than air. So as moisture decreases air density, causing it to rise. So moisture decreases, air becomes denser, tends to sink. Okay. If we have water vapor taking up the place of air molecules, and the water vapor is lighter than air, that air is going to rise. With less moisture, it becomes denser, because now you just have a bunch of air molecules packed together. Now it's going to become dense and sink. That water vapor is adding to how light the air is, how less dense the air is, which causes it to rise. So more moist air is rising, which is why we have the moist adiabatic lapse rate. You can write it varies from between 1 and 3 per 1,000 feet. Then the dry rate is 3 per 1,000 feet. Unsaturated air. Okay. Pressure. No. Okay, we should have started with the first slide. Unequal heating of the Earth's surface is the source of all weather. Unequal heating of the Earth's surface is the source of all weather phenomenon. So the unequal heating is not only modifying air density and creating that circulation pattern that we just talked about, it's also changing air pressure. By pressure, we're talking about the force exerted on the weight of those molecules that we keep talking about, those air molecules. So we've already known from Weather Week, air molecules are invisible, but they have weight. And we keep talking about how they're moving and creating less dense air. So the pressure, we know the pressure of the air, it's lower as we ascend, as we increase in altitude. That's what we're saying here. Standard pressure, what's standard pressure in inches of mercury? 299.2 in millibars, someone already said it. 1013.2 millibars. Okay, there it is, 299.2. Standard temperature, you also need to remember for performance calculations, 15 degrees Celsius. Or if you want to stay in Fahrenheit, 59 degrees Celsius. Okay? There's the big idea. As altitude increases, atmospheric pressure decreases. Pressure systems. I have to pull up. I mean, this is where you would want a picture in slides. Really. Okay, this is what we got going on in California right now. It's rainy, which is unusual. So all of this rain, maybe thunderstorms around here. What are all the pressure systems around this unstable air? Low pressure. It's creating all this unstable air. Vertical motion plus visible moisture. We'll go over back to what creates a thunderstorm, but you can easily tell there's low pressure systems all over this area and then high pressure out here. And then we've got a cold front coming in from the coast into California too. This is also adding to all the weather activity that we're getting right now. This is kind of clicking now that we see it like this, that we actually have weather in California that isn't just fog, that you see this cold front coming in. What's a cold front doing to the air? Pushing warm air up. Dense cold air works like a snowplow. It's coming from the bottom and pushing that warm air up, creating vertical motion. Now we have low pressure systems all along here, and connecting between each of these low pressure systems, there's what? What is this? It's a trough. It's just an elongated area of low pressure. So this is why all the low pressure systems are connected by troughs, just elongated areas of low pressure. All of this is low pressure systems. Okay, up here in Canada, we have this piece of the front. What is this? Stationary front. How does it work?
The force is pretty.
Right, a standoff, right? The cold and the warm front, because it's going back and forth from the cold and warm front symbols. The cold and the warm front are both not strong enough to move the other out of the area. So they're kind of equalized, but they're not fully equalized. They just both aren't strong enough to move the other out of the area. So they're at a standoff and they're keeping whatever weather happening in this area, they're keeping that there for the next couple of days instead of moving out of the way. Then we have, there's, no, okay, the only front out here. So this is a warm front, right? We all know that. How's a warm front move? Like a blanket. Slowly is the part that we want to remember from like a blanket. It moves slowly and over top of cold air like a blanket. Okay. And it looks like there are literally no warm fronts in the entire country except out in the ocean. So there's a lot of convective activity all around here. And I don't see one in Texas. I can't ask you about it. And I can't, oh, there's one here. Yeah.
Are there great lines for wind?
Oh yeah, what are the gray lines? Isobars. Yeah, what are isobars?
When they're closer together, the winds are stronger.
Yes. Closer together, the winds are stronger because you have a steeper pressure gradient. They're farther apart, you have a less steep pressure gradient, so you have less strong winds.
And the fronts are from.
The isobars, these gray lines right here with the little numbers next to them, this is pressure in millibars. So like 1013 is standard, right? So this is above 1013. That's why we have a high pressure system right here. Makes sense? Yeah, so these ones are kind of closer together compared to like these over here are a little farther apart, so there should be stronger winds over here. Isobars are equal, or yeah, equal area, equal pressure areas. Oh, back up here, last one. What is this purple? An occluded front. How's it form? How does it move? Exactly. Exactly. I have nothing to add to that. That's exactly what it does. Okay. Other weird things that could be on here are dry lines. What do dry lines look like? Do you remember from there's nothing on here, I can't find one. But they have those little scallops on the side. They look like this. But they look sort of like this. They have a scallop side and a side with nothing on it. The side with nothing on it is the side with dry air. And the little scallops on the other side shows that there's moist air on this side of the dry line. Okay. Then otherwise there is a yellow, I think. Can't remember what color it is. Also looks like a trough, but it's for high pressure. What's it called? An equal, or not an equal, an elongated line of high pressure. It's a ridge. Good job. I think it's yellow. This is kind of like brown, orange for a trough. I think ridges are yellow lines, but I can't remember. Someone look it up. I don't see anything different on it. And it looks like a mountain. I think it's yellow, and it looks like, I think it looks like this. No, anyone confirm or deny if it looks like this? Looks like ridges of a mountain, squiggly yellow. No. Well, where to find the legend? You all are really bad with legend.
Yellow or brown zigzag.
Okay, I still got it. Okay, so it kind of makes sense. If you're looking at a squiggly line, remember like a ridge of a mountain, and that's like the highest point, so that's going to be high pressure areas, whereas a trough is the lowest point. So that's showing you elongated areas of low pressure. That should be it for, oh, no, that's not it. Ask the biggest question. I'm gonna just go. Okay, around this high pressure system, how's it moving? Don't say it out loud. I'm gonna ask them. Omar, how's it move?
No.
Good. Clockwise, downwards, outwards. High pressure. Low pressure, you can infer from the opposite, counterclockwise, upwards, inwards. Again, if you can't remember, think of putting a lid on, taking a lid off. Putting a lid on is high pressure, you're screwing the lid on clockwise, you're pushing down and out. Taking a lid off, you're pulling it off, you're coming up, and you're unscrewing counterclockwise. Okay? Okay, that's it. That should be all the slides as well. For pressure system release. There's some more images to let you know how it moves. There's the arrows. Okay, what's Coriolis force? Someone other than Spencer. Or Harper. Or Alex. I get the same 3 people answering all the time. Okay, try.
Is Coriolis force, they described it as when you throw a ball, whether you're relative above the equator or below the equator, has a different effect because of the way that the Earth is spinning.
Yes, the Earth's rotation deflects air to the right in the northern hemisphere. We don't care about the southern hemisphere, it's going to deflect it to the left because it's opposite. But from the northern hemisphere, because the Earth rotates around its axis, if you were at the North Pole and you were throwing a ball down towards the equator, the ball would deflect to the right because the air is rotating or deflecting to the right because of the Earth's rotation. There it is. Air deflects to the right in the northern hemisphere due to the rotation of the Earth. This is all you have to understand. Don't overcomplicate it more than what I just highlighted, okay? It's following a curved path instead of a straight line because the Earth's rotation is deflecting it to the right in the northern hemisphere. It's opposite in the southern hemisphere, but we don't care about the southern hemisphere. Then they also want you to know that within 2,000 feet of the ground, the friction between the surface of the ground and the atmosphere slows moving air. That's really all it is. Wind is diverted from its path because of frictional force. So thus, the wind direction at the surface varies somewhat between the wind direction at a couple thousand feet in the air. Okay, I think that makes sense. The ground creates friction between the atmosphere. It's moving in a different direction on the ground than it is a couple thousand feet up, moving up and up. This is why we have the winds aloft chart that shows us the wind direction and speed up thousands of feet so that we're able to see how wind's moving up there, not just calculating or getting readings of wind close to the ground. We need that winds aloft chart because it's moving differently than it is right over the surface of the ground. Okay, we already went over this. You should know that. This is back to High pressure clockwise, low pressure counterclockwise. If you want to confuse yourself and think about cyclonic and anticyclonic, think about hurricanes. Our cyclones, they move counterclockwise. That's it. Convective currents have to do with the land absorbing solar energy quickly rather than like the trees and the bushes and all the other lakes and water and things. The barren land, rocks and sand and all that absorb solar energy quickly and therefore give off a large amount of heat. Water and trees are slower, so they're more slow to absorb heat and give it off. So, for instance, when we're coming into land at Compton or Torrance and you're flying low to the ground over all these buildings that are basically barren land, no trees over there, you're getting convective currents, getting that turbulence right over the ground because that warm air is being heated so fast, it's moving upward. That's why you get the little bumps right before on a very hot day, you get bumped around right before on like short final, right before you get to the runway. Those are convective currents because the ground is being heated very fast. The solar energy is absorbing quickly and then giving off, that air is rising fast. Compared to an area if we were flying over a bunch of fields with trees and other things. Okay. Mountainous areas, we talked about air flows down the leeward side and up the windward side, which creates what kind of clouds on top of the mountain? Lenticular clouds, good. It looks like a lens, shaped like a lens on top of the cloud. That's indicating severe turbulence over top the mountain. How high should we fly above the mountain to avoid mountain wave turbulence? It was part of the quiz for slaying that we took. We didn't go over a slide on it. It's not really in any of the books, but it's probably going to be safe to guess 2,000. Good. 2,000 feet is what they want you to know. 2,000 feet over the peak of the mountain. So 2,000 AGL. You're adding that on above ground level of the top of the mountain. 2,000 above that. Okay. Wind shear. We had some pretty bad wind shear yesterday. Who was flying when the PIREPs were reported? Yeah, I was flying too. I had to take the landing. I nailed it. My student was like, hell yeah. I was like, yeah, I still got it.
That's fine.
I don't know. I was like, yeah, you don't have to clap for me. You weren't there, but but it was it's interesting because it's good practice if you're up in the air to practice. I mean, you want to challenge yourself. You all are just learning landing, so you want to be challenged at some point, but you need to know your limits of how much you can handle at this point. So does that mean when you're up in the air and you have to land, yeah, you're gonna have to figure out with your instructor, or if you happen to be solo, you're gonna have to figure out what your limits are and if you're gonna push yourself to do this landing with reported wind shear. Because right before I landed, I think it was a Cessna made a PIREP that they lost 10 knots over the runway and 100 feet. So that's pretty bad, right? That's really, really, really bad. The wind shear, first of all, what's wind shear? A sudden change of direction or wind speed over a very small area, which is going to be the worst wind shear is low level wind shear, which means it's right on top of the runway. So we're coming in low to the ground and we're slow and we have less control over our control surfaces because we're slower and we're getting less wind over those surfaces. So if we get knocked by some low level wind shear that's suddenly the wind changes direction and hits you from either a headwind, a tailwind, a crosswind, you aren't going to have a lot of control over the aircraft to fix that so low to the ground, okay? So you need to consider what your limits are when you're flying. Your limits should be pretty low right now because you just learned to land. Like you want to step up. Your personal minimums is probably a better explanation of this. If you haven't talked already with your instructor or learned about personal minimums, we're going to talk about it at some point. You have to talk about those in your check ride with your DPE about your set personal minimums. personal minimums are not just in your head of, okay, I think I can handle this, this, and this, maybe on a certain day. Your personal minimums when you show up for a check ride and in general should be set on paper so that you follow them. This is how pilots kill themselves because they do not set personal minimums and follow them without a doubt. If you set personal minimums, you need to check those before you go up in the air. And if you don't, if whatever weather minimums you set for yourself or wind minimums for crosswind component you set for yourself, if it's reporting higher than that, you have to make a no-go decision. Because if you go up to test yourself by yourself, if you go up with an instructor, it's different. They're there to help you. They can teach you on like tougher days of lower ceilings or higher wind or wind shear. But going up by yourself, you have to have very strict personal minimums and adhere to them. That's the point of writing them down, is not to just go up anyway. Write them down and then with your instructor, move your personal minimums up and up and up as you get more experience. But right now, you barely have any experience. Your personal minimum should be at least slings standards, if not lower. Okay, so wind shear yesterday was very bad. You were losing, people were losing 10 knots above the runway. They were losing 100 feet because that wind was coming in, losing airspeed. Where do we think the wind was coming from? That's slowing us down. A headwind, right? The wind is suddenly changing to a stronger headwind that's slowing you down. That's why they got reduced by 10 knots right over the runway. The problem, we already know, it's associated with passing frontal systems. That's that weather that was coming in that's here now today, was coming in yesterday. So you could see outside, the wind was shifting every few minutes. The cloud coverage came in. It became like dark outside. The winds were increasing. This is how you know something was coming. You could tell just by looking outside. There's a passing front. Thunderstorms are coming. You could expect temperature aversions, strong upper level winds as well. Okay. So good practice if you happen to be up there and landed in that wind shear with your instructor, but there's a difference between being in the air in those conditions and then making a choice to land or practice landing. If you're already on the ground, if you were on the ground yesterday and you read a PIREP that said they've lost 100 feet over the runway or they lost 10 knots because of wind shear, that's when you need to make a no-go decision for the flight, which is what I did for my next flight after I landed that. I'm not taking another chance of, okay, I landed that well, but that doesn't mean I need to go back up again and risk landing in wind shear again. Even as an instructor, I'm making that decision. Because I could have gone up with my instrument student and took the landing again, but you have so many days left before you to fly. Do not make the decision to fly today because you need to, and you have 0 days left to fly because now you put yourself in some kind of situation that is possibly dangerous, okay? There will always be more days to fly. Make a safe decision, like most people did. Barely anyone flew yesterday after those PIREPs. So make a safe decision with your instructor right now. But when you start soloing, once you solo and you're marked off to take the plane up by yourself, you'll do, you'll do the 3 takeoffs and landings as like a ritual for, okay, I did my first solo. But after that, you're able to take the plane out solo to the practice area or to wherever airport your instructor signs you off and endorses you to. You will be flying the plane by yourself, going out to the practice area, coming back in. You have to make these decisions on when is safe, what conditions are safe for you to take off and to land. If you were to take off and come back in and that PIREP came over the radio, like it was so bad that they repeated it like 3 times to me as I was coming into land because they really wanted us to know that it was extremely dangerous to land. If you hear that and you're solo, what can you do? Cry. Okay, one biggest option is if you want to attempt to land, be ready at every single second to go around. At the first thing where it feels wrong, go around. Make that decision every single time. Even better than that, if you're hearing a PIREP at Torrance and you don't feel like I haven't ever landed with wind shear before, I don't feel confident, and what I'm doing, make that decision yourself. It's perfectly fine to make. What else can you do? Go to a different airport, go land at a different airport. They will not fault you for making that decision, especially when a PIREP is being issued for that severe low level of wind shear. They will not fault you. So forget the plane. Who cares about who has the plane after you? Whatever. They'll find a new plane. They'll fly another day, whatever. Make that safe decision for yourself. If you try it and you have to go around, you're like, screw that. That's way too much. I can't, like, I tried. I had to go around. I don't think I can do it. Go to Long Beach. Go to Compton. If it's better, you can land at Compton and sit the plane over on the side of Compton. Go to Long Beach, go to Hawthorne. If you're cleared to whatever airports that your instructor has endorsed you for, El Monte, some people go up to, whatever airport you've been practicing at and you're cleared to, go to that airport. They, like yesterday, Long Beach did not have the same low level wind shear that we were getting at Torrance. Make the decision to go land somewhere else, contact your instructor, contact dispatch, tell them it was unsafe to land, I'm student solo, I made the decision to come over here, I'm gonna wait it out. Or at Long Beach, easy, there's slings over there, you could taxi to the sling facility, talk to an instructor over there, and you can make another decision to go back up, or go with another instructor back over to Torrance. There are a lot of different options. Don't put yourself into a corner where you feel like you have to land because we're on a schedule, because someone needs the plane next, because you're already up in the air, you've got to land anyway. It's never the case. You don't have to land at this specific airport. Eventually, it is the case you do have to land. You're going to run out of fuel at some point, but if the conditions are bad, you do not have to land then and there. Don't put yourself in a corner where you feel like, I have to land right now, my plane is late, I have to make this landing, we have to get on the ground. That's never gonna work. That's never safe. That's never gonna be a good outcome. Even if you do make the landing, it doesn't help at all to make that decision if you just worked out the landing and made a bad landing coming back in. You're like, at least I'm on the ground. That's not helpful either. Okay? There's my serious talk right now. But because we had wind shear yesterday, I feel like a lot of people were back and forth on if they should fly. And right now in your position as a student pilot who just learned how to land and probably nobody that I'm aware of has done their solo yet. There are 3 takeoffs and landings. Okay. At this point, you're with an instructor, but once you get that solo endorsement, be mindful of how you're using it. Be safe. Be overly cautious right now so you can have the time to make yourself a better pilot later. Okay? That's the underlying. Be overly cautious. Don't put yourself in a box. Don't feel like you have to get all the experience right now, or I don't know. This is the thing that I can't remember every time. Hazardous attitudes. That's what we're talking about. Hazardous attitudes. It's probably more like, what's the one? Macho. That the majority of the class probably has a problem with, but probably not the front row has a problem with, except for 2, but macho tends macho just because you're guys, not because of your actual personalities. No, I can't say that. It's proven many, many times that the macho attitude is a Y chromosome thing. It's not an X.
I'm trying to say we approached.
Is that what macho means? No. We've seen from the decisions people make, you tend to be like, yeah, man, I can do it. You hype each other up. You say, yeah, I'm gonna go up there. Hell yeah, I got it. Hell yeah, exactly. I say it all the time. You're joking, but I hear that literally come out of people's mouths for real. Talking about PIREP yesterday. Bro, I got it. I'll go up there. Whatever. Do you. Good luck on that landing. And hopefully I see you tomorrow is what you would say, okay? All right, let's go over fog. Now that we've gone over okay, cloud bases. Do we remember the equation? You might be asked. Definitely this is a written thing, right? The determining cloud bases. It's on the written? Okay. You're gonna have to memorize the formula. So you're starting with dew point and temperature At the surface, you figure out the spread, then you divide the dew point temperature spread by the convergence rate. So you have to figure out if you're in Celsius or Fahrenheit, 4.4 versus 2.5. Then you multiply whatever that is by 1,000, then you've got your cloud base. Okay? Start with your temperature dew point spread. They're always going to give you temperature and dew point, and then they're going to expect you to figure out the difference, figure out if it's in Fahrenheit or Celsius, divide that by whatever Fahrenheit or Celsius is, then multiply that by 1,000. Then you've got your cloud base. Okay? Memorize it. It's on the written. Easy question to get right on the written, because all you have to do is do the formula. Okay, what is the most common type of fog at Torrance? Yeah, we've been seeing advection fog for the past like 2 weeks, right? Every time you wake up and it's like 9 a.m. and you're driving to the airport, maybe to do your, they've been pushing it back to 11, but you're driving to the airport and it's complete overcast. And then by 1 p.m., it's usually completely burned off. And the sun comes out by then. So that is advection fog. So someone explain advection fog, please. What's happening with the air? Yeah, Alex.
Should hold on, pull out.
Perfect. Warm, moist air, from example, from the coast, from the ocean, is moving over a cold surface inland over the colder ground. It's condensing when it reaches that dew point and creating low to the ground clouds, clouds that are on the surface. That's what fog is. Clouds that are on the surface. Okay. What about radiation fog? How does radiation fog form? Somebody, anybody?
The terrain,
Mm-hmm.
it's the heat rising, or yeah, it's the heat rising from the ground.
Mm-hmm.
Um, remember the rest of it.
That's the beginning. So the ground is warmed by the sun throughout the entire day. So the radiation fog is usually forming at night on calm, cool nights. Calm meaning no wind. We can't have wind with radiation fog. So the ground that's been heated all day heats the air right above the ground. That air rises as it heats. And then as it's rising, it's also cooling to its dew point. Once it reaches its dew point, it's condensing into fog that ends up right over the ground. Okay? It needs no, let me go to the slide. What, that's upslope. Hello? Radiation fog. Little to no wind present. Okay? Low-lying areas like mountain valleys, the ground is cooling rapidly due to terrestrial radiation. The surrounding air temperature reaches its dew point, creates clouds on top of the ground, which we call fog. Okay? Advection we talked about, upslope fog, pretty simple. It's also warm or moist, stable air being pushed up the slope of a mountain. By pushing it up, air is rising up the terrain, and as it cools to its dew point, it's creating, or it cools to condensation temperature, reaching its dew point. Now form as fog. The fog is formed on the slope. Requires wind, right? It can't be pushed by, it has to be pushed up the side of a mountain. So wind is required for advection fog and upslope fog, not radiation fog. Steam fog, what's steam fog? We're all looking at it. Good. Cold, dry air moves over warm water. Ice fog, pretty self-explanatory. It has to occur in cold weather where the temperature is much below freezing and the water vapor forms directly into ice crystals. So it's usually negative 25 degrees Fahrenheit or colder. And clouds, we have low, middle, and high clouds, and then clouds with vertical development. Low clouds, stratus clouds, and the other variations of stratus clouds. We have middle clouds, those are going to be with the prefix alto, alto stratus, alto cumulus, and then high clouds, cirrus clouds, and the other variations of cirrus clouds. Okay? Stratus, alto, cirrus. Yeah.
So stratus and cumulus
Mhm.
are basically just relative to stable or unstable air, right?
Yeah.
So it's still
like
the
a-
same type of cloud within
Yeah.
the range, but you're just saying it's either stable air or it's unstable air.
Yes. And the other types where you're adding to it are like it's an umbrella term with different types underneath it.
Yeah.
Okay. Then obviously clouds with extensive vertical development. We know vertical development leads to instability. So that means their air around them and inside them is going to be turbulent. And if they contain moisture, moisture and unstable air produce hazardous weather, like all of these examples. Okay, if you have a towering cumulus cloud, so a cloud with extensive vertical development, and it reaches all the way to the jet stream, then we have something called an anvil top, where the jet stream cuts off the top of the cloud. That's the anvil top. And then otherwise, here's some examples of stratus close to the ground, alto cumulus, alto stratus in the middle, and then cirrus clouds, those wispy ones, are high clouds. Okay, there's more pictures. Got it. We already talked about lenticular clouds. Nimbus, the nimbo prefix is, or suffix in this case, is rain-bearing cloud. Fracto or ragged or broken because wind is shearing off the sides of the clouds. So it becomes fracto clouds. And then cumulonimbus clouds, thunderstorm clouds. Huge vertical development. They have moisture inside of them. They're rain-bearing thunderstorm clouds. Air masses. Don't really care. Okay, we already went over fronts when we looked at the Prague chart. And convective activity, okay, thunderstorms. We aren't into, there's two major types of storms that are considered convective activity. They are issued, or signets are issued, convective signets are issued for these types of thunderstorms. Embedded thunderstorms, meaning the thunderstorm is inside, it's a cloud, you can't see it. Storms are hidden inside a thick line of clouds. Squall line, we talked about a system of thunderstorms that is formed into a line. It occurs often ahead of a cold front, where wind shear combined with unusually widespread lifting. So this makes sense for what's happening in California right now, right? Often occurs ahead of a cold front. We saw that cold front coming in from the ocean. That cold front's still over the ocean. So this system of thunderstorms that's coming in right now is ahead of that cold front. And we just experienced wind shear yesterday. So we probably are getting squall line thunderstorms. Okay, requirements for a thunderstorm. Someone tell me the 3 requirements. Yeah, Harper.
I have a good one.
Wait, give it to us.
Okay, imagine a thunderstorm. It's a scary.
Do you want to write it
MIL.
out?
No.
Okay.
So, MIL, moisture,
Mm-hmm.
instability, so it's unstable air, and lifting force, which would be rain, wind. So
MIL, mother-in-law. Everyone got it? Moisture. Good job. Moisture, visible moisture, unstable air, instability, and a lifting force, which she talked about could be a bunch of different things. There it is. Unstable atmosphere, lifting mechanism, sufficient moisture. Good. Okay, what are the 3 stages of a thunderstorm? Not heartbreaking. She's too good at weather. Somebody else. I know you know it too. I need somebody who doesn't look like they know it. Who actually knows it. I think Max knows. What are the 3 stages of a thunderstorm?
Gosh, I feel like
Oh, I got them.
You do sound like.
I know it.
Yeah.
I've done it. It's been.
It has first.
I know it's like first, middle, and end, but I don't know. I don't remember what they're
So,
called.
wow, Victor, help him out.
Cumulus maturity.
Cumulus, mature, dissipating. Cumulus can also be called developing, if that
Oh.
helps you remember. Developing, mature, dissipating. So, developing or cumulus stage, what is it characterized by? Lots of people in the back are looking away. Characterized by updrafts. The mature stage is characterized by what? Alan, what's the mature stage characterized by? Of a thunderstorm. Not the clouds. The cumulus stage is the first stage. The second stage is the mature stage. Characterized by what? Edwin, characterized by what? He put his phone away fast. Mature stage characterized by what in a thunderstorm? Okay, moisture in the air, but it's fully saturated. So what's happening now? Precipitation, there you go. I can see you're getting a little help back there from your friend. Then dissipating. No, help each other out. If I'm calling you out, you can tell each other what the answer is, but I need to call on some other people who aren't obviously knowing all this. And then the last stage is the dissipating stage. What stage or what is it characterized by? Charlie? Downdrafts, easy. Good job. Okay, there it all is. Mature stage, dissipating stage, lightning. Obviously, lightning is dangerous. Tornadoes can occur both isolated and within squall line thunderstorms. Okay, let's get to. Okay, icing. What are the 3 types of icing? Yeah, Abby.
Clear,
Mhm.
rime, and mix.
Clear, rime, and mixed. What's the most dangerous type?
Clear.
Clear ice. Why? Yeah. Alex gave me. Alex gave me the. Okay, that's one reason. We have a couple, right? One reason is you can't see it.
Changing the surface.
Changes the surface of the wings, so that means that what's inhibited?
Airflow.
Airflow. Yes.
Disrupted.
Airflow is disrupted, and then the last one. Weight. It's adding weight to the wings. Okay, because do we actually know how? I'm sure some of us do, but how is clear ice formed? Do we know?
It's like rain that goes like forms in like an icicle as it goes back.
Not necessarily an icicle. We have a specific word for the type of droplet that is. No, the girls know it. Anybody else? It's called a large, supercooled droplet. Okay? So large, supercooled droplets, they call them SLDs. Large, supercooled droplets, meaning it's a large droplet of air compared to with rime ice, there's a smaller droplet. So that large droplet of water is hitting the surface of the wing, and it's not immediately freezing. It's rolling back on the wing, and it's creating a sheet of ice over top of the entire surface of the wing, all the way back to the trailing edge until it freezes. So it's freezing as it's rolling back. Yes.
Is that like different than hail?
It is different from hail because hail's already formed, crystallized into
So
ice.
it's like water.
Exactly, it's just water, but it's a larger droplet that's already super cooled. So it's already almost at freezing temperature, and then once it hits the surface of the wing, it doesn't immediately freeze because it's a larger droplet of water. So it starts to roll back across the surface of the wing back to the trailing edge, and it freezes as it's rolling back, creating a sheet of ice on top. Yeah.
Does it freeze when it hits the wing? Maybe it's colder than the atmosphere.
Not for clear ice, but for rime ice, yes. For rime ice is smaller droplets of water that are super cool that are hitting the surface of the wing and are immediately freezing on the leading edge. Yes.
I don't know the science behind it, but you ever seen like the water bottle video where it's like they chill it and like you slam the bottle
Yeah.
and then it like turns to ice.
Yeah.
Is it kind of like that?
Kind of like that, yeah. Because it's back to what I talked about. I can't remember what day, but I talked about how the surface of the wing can be at below freezing than the outside air temperature. So that's happening here. The surface of the wing is at a temperature below freezing, and the outside air temperature is above freezing because you have water droplets. If it was below freezing, you'd have ice falling, ice crystals falling from the sky, or hail if they're forming into balls. So because the outside air temperature is above freezing, you have water droplets. They're hitting the surface of the plane that is at a temperature below freezing, and they're freezing immediately on contact, which means they're building up on top of the leading edge. Yes.
Would that be a difference? Where's that?
Freezing rate is a little bit different because it's freezing as it falls instead of because it's hitting the surface of the wing. It's starting as rain from the cloud, and then as it's moving into below freezing temperatures, it's freezing as it's falling. But it's kind of the same idea as it's starting as a droplet and then becoming ice as it hits that below freezing temperature. But freezing rain would just be out. The below freezing temperature would be in the air, but lower as it's falling to the ground. And then the surface of the wing is creating that below freezing temperature. And as the droplet hits the surface of the wing, it cools to below freezing and immediately freezes on the leading edge of the plane. So it's creating like, actually, are there pictures in here? Tip, do you have a question?
When Virga is reported, is this the type of missing on the wing that?
Virga is the streaks underneath the streaks that you can see underneath the clouds that are telling you that the water is evaporating before it hits the ground. So we don't have to worry about icing at that point because they're no longer water droplets. It's as it's falling, the water droplet evaporates before it can reach the ground. So it's getting to a higher dew point temperature. So it's not a water droplet anymore. So we don't have to worry about it getting on the plane and becoming ice. Rime versus green. Glaze, frosting versus icing versus glaze. That's not what I'm asking. Okay, rime ice. Kind of looks weird, but rime ice, you see how it's all like bubbly and frozen on top of each other? There it is. It's built up on the front of a surface. This isn't a wing, but you see what I'm saying? It's like bubbly, rough surface because it's just each one is hitting and creating like a little freezing droplet, a little piece of ice on top, and it's just building on top of each other. And it's freezing on contact, so it's never moving back behind the surface of the wing. Now, clear ice. There. Clear ice is a sheet of ice that's created. You see how you can see how the droplets are running down and freezing as they're dropping?
Like an ice.
Yeah, like an ice. Except when it first hits, as it runs back, it creates like a longer sheet of ice on top of it. There's I have a lot of good pictures. I'm saying that's mixed ice. That looks like another clear ice, right? It's kind of smooth. Freezing as it rolls back creates like a kind of smooth surface instead of the rime ice creates like a bumpy looking ice on it. These all kind of look the same, but this is the idea. Super large, super cool droplets or clear ice are making contact with the surface of the wing, but they aren't frozen yet. They roll back across the surface of the wing towards the trailing edge, and they freeze as they're rolling back. That's what creates the sheet of ice, and that's what creates the weight that makes clear ice dangerous. And I don't see any better pictures, but you get the idea. None of these are great. A lot of the pictures they come up with aren't real pictures.
Tasty.
I'm looking for a real life version of clear or rime ice on a wing.
Oh. Should buy myself.
Oh yeah, is this the one we looked at? This one? This
Oh,
one?
this one's crazy.
That one's crazy.
I think the one is so.
Yeah, I was gonna say I can't see it. Okay, that one is crazy, yeah. That one formed in like the crystals. It's like here's okay. We get the idea. Hail, we're worried about in a thunderstorm, right? That's why we're staying 20 nautical miles away from a thunderstorm. Other service types we got, okay. Sigmets and airmets. What are the 3 types of airmets? Who said it? Charlie? Tango, Sierra, what was the other one? Zulu? Okay, who can tell me about Zulu? Oh, you all can. Yeah, Alex. Moderate icing conditions, good. What about Tango? Ethan, yeah. Turbulence, moderate turbulence specifically. Moderate turbulence, and then Sierra. Sierra. Mitch, yeah.
Obscuration,
Mountain obscuration and IFR conditions. All right, easy enough, right? Airmets are easy. Sigmets, well, who are they publishing airmets for? Smaller general aviation aircraft. Sigmets are published for all aircraft. What is a Sigmet telling us?
Severe.
Severe weather. So one example is severe turbulence. The other? Severe icing. Then the other 2? Sandstorms and volcanic ash. Good. Now we get into convective Sigmets. We have a couple conditions where a convective Sigmet. What's the first major 2 that we're talking about? Yeah, a severe thunderstorm with greater than 50 knot surface winds, good. You also have severe thunderstorms with hail greater than how much? 3/4 of an inch. Then we have just on top of that, what are the types of thunderstorms other than severe thunderstorms that they're issuing for? Embedded and squall line, good. Lastly, severe thunderstorms with what type of precipitation or what category of precipitation? Good. 40% of a 3,000 square mile radius. 40% and 3,000 square mile area.
Yeah, it's pretty.
And tornadoes, good. That covers all of them. Okay. TAFs, winds aloft, and METARs. Do we feel good? Yes. What does the what's it called? What's the dollar sign mean on a METAR? need money, needs repair, okay? What about, okay, let's look on this one. What's the 999 mean? We back and forth?
Thank you.
Somebody look it up. Yeah, what should be there? We have winds right there, so it can't be winds calm. We have clouds right here, so visibility is supposed to be right here. So this is another way to say visibility, but this is going to be for a TAF for EWC. It's very. What do I have on here? JHW. Where is it? We don't have another example of that, but just look where it's filling in the METAR. But this is a tap here, so it's filling in on the tap. Then we have becoming on all these. I don't think we've seen a tap that says this, but it's becoming instead of temporarily. BECMG means becoming between this day on the 16th on or at 8 Zulu to the 16th at 9 Zulu, variable winds at 6 knots, 8,000. What does the minus straw mean? Light, showery, and rain. Good. And then overcast at, so this one, overcast at 700. So that's our ceiling, right? Our overcast layer is our ceiling. What about if it says overcast at 700 but it has a CB behind it? What does that mean? Cumulonimbus clouds. Okay. And then obviously, like I already told you guys, if there's something that you don't know on the TAF or the METAR, pull out your legend. Easy enough. Look up what it means on the legend. And we talked about with the quiz when we finished today about abbreviated outlook standard. Hopefully everyone understands that standard is always what you need to fly. You're required by law to look at the weather before you fly. Get a standard briefing before you fly. Outlook is if it's more than 6 hours away, your flight, yeah. Oh, right now? We have to come up with a flight to give them.
Albert,
Palomar?
still thinking about it.
Thank you.
And so
It's gonna be a lot to call. Does everyone?
so
What's these?
Yes.
if you don't have this info,
Need to tell them what's like.
Mhm.
Yep, or.
Yep.
And then.
Yep.
Route in
Mhm.
destination, altitude, departure time, just ETA into.
That's a lot of information. You might have tried to do it, but again, I have to let them know before this isn't real. We're practicing, which you can do. You can practice. Also, I thought about this the other day when I was talking to my instrument student. I said the wrong thing when we were talking about filing, because I was thinking about my instrument student who cannot file. You can file as a student pilot for your VFR flights, but again, the same idea applies. Talk to your instructor if you're going to file, but don't just file and not tell anyone that you're planning on filing, because you have to activate the flight plan with tower when you get on. They'll see your tail number and they'll see that you have a flight plan. So you activate it with them, and then does anyone know what happens at the end of the flight? If we activate it, we've got to close it, right? So you have to actively close your flight plan with ATC or by calling flight service station to close it. Does anyone know the timeline on how long you have after your ETA? It looked like 6 hours? No, way too long, shorter.
45.
Alan, yeah. 30 minutes, good on. You have 30 minutes to actively close, which means you have to talk to someone either on the comms. Once you're landed, you'll tell tower to close your flight plan. Or if you forget, then you've got to call afterward on the ground to let them know that you've landed, that you're safe, and they can close the flight plan. They don't automatically close it as soon as you land. They're not looking at, okay, they just landed, that means their flight plan is closed. You have to take the responsibility to close your flight plan with them. Otherwise, if it gets after 30 minutes, they're gonna come looking for you. They're gonna send out people, maybe not a search party yet, but they're gonna send probably contact to the airport you're supposed to be at to figure out if you're there or not. And we don't want to use resources that we don't need. So yeah, I remembered that I need to tell you all that. What I was thinking about is if you're an instrument student, you can't file because you aren't an instrument pilot yet. An instrument pilot under filing the IFR plan or flight plan has to have an instrument rating to file. That's not the same for VFR. You can file as a student pilot. You just have to be aware of what it means to file and talk to your instructor so you both can handle the activation and the closing of your flight plan. Okay? Okay, now that I clarified that, that's all I really have for you. We tomorrow have a quiz. I guess it's gonna be a review quiz of all of it. I haven't looked at the quiz yet, so be prepared for questions about everything that we talked about the first 5 weeks. And we're gonna start off with the quiz tomorrow. No review because we've done review the entire week. So we'll start with the quiz and then the rest of class will be going over what we missed on the quiz. Okay?